Okay, so today we're going to be going over graphing square root functions, and the only thing that's different from graphing parabolas or graphing absolute value is the parent graph. So whenever you see a new equation like the square root of x, you just make a table. So when I do the square root of 0, that simplifies to 0. And notice this time our x's aren't the traditional table. So this is a traditional table where your x values that you pick are those 5 points right there. This one just has 0, 1, 4. The reason for this is because we can't plug negatives into square roots. And then also we don't want to plug in like 2 because then we'd get the square root of 2, which we could graph, but we don't want to do that. So, okay, then we have the square root of 1, which is just 1. No more square root sign. And then the square root of 4, which we know is a perfect square, so that would simplify to 2. So these are the 3 points that we're expecting you to know for square root graphs, and this graph is known as the dolphin jumping out of the water. Whew, if you see it. Okay, anywho, so when I say it's the dolphin jumping out of the water graph, that's what a square root graph does for us, okay? So now we're going to do transformations, and you guys know this. If it's in with the x, it's going to move the x, but it's always opposite of what you think. And if it's not in with the x, if it's outside, then it's going to move the y. So this is outside, this is inside. So not with the x, in with the x. Okay? So this one is going to go down 2. This one is going to go up 1. So on your homework this time, last time I didn't require it, but on your homework this time, I definitely want you to write these transformations. Whenever it's in with the x, we either set it equal to 0 or, we always set it equal to 0 so that we make sure we're doing what we should be doing. So this one's right 1. This one is going to be subtract 1, left 1. So we'll get to these graphs in a second. We're just making sure we understand what's going on here. I definitely see a down 2 because of that not being in with the x. I just got to do a tad bit of work to figure out what's it doing horizontally. So that's going to be, ooh, that's not right. That's left 3 because it's negative. So left 3. This guy, x minus 2 equals 0, x equals 2, so we're going to go right 2 and then up 1. This one, if the negative is out in front, reflect over the x-axis. And then right here, I have that same thing, reflect over x-axis. And then x plus 4 equals 0, x equals negative 4. I'm going to go left 4 and down 1. Okay, so those are all the transformations on those graphs. Let's go ahead and graph them. It's really nice with the square root graph because we only have 3 points. With parabolas, which are these guys, right? Let me just remind you. Parabolas. Those are these guys. We have 5 points. And same thing with the absolute value graphs. We have 5 points. But with square roots, the dolphins, there's only 3 points. So I'm going to plot my points, and then I'm going to use a different color to move all my points down to. Okay? Done. So I have only graphed the G graph. This is F. This is our parent graph because I just needed those points to move. If a question ever says graph the parent graph and the transformed graph on the same grid, then you would need to do that. So I moved them all up 1. Let's move on. We're kind of just going through this quickly because other than these 3 points that are new, you don't have anything else new to learn. So we're going to stretch these like we did before, and we're going to compress them, but we don't have all that other stuff. I mean, there isn't any other stuff. There's just like, you already know everything. There's nothing new for this. So I am going right 1 on this one. Okay, and then this one I'm going left 1. So every point just gets moved left 1. Alright. Then here I'm going left 3 and down 2. Nice. So left 3, 1, 2, 3, down 1, 2. Left 3, 1, 2, 3. I guess I should do it like this. Left 3, 1, 2, 3, down 1, 2. And if you kind of already know the pattern, you don't have to move every point. So it's up 1, over 1, up 1, over 3. Okay, kind of like parabolas, there's a pattern there. That one's up 1, over 1, up 3 over 1. This one's the reverse because they're inverses of each other. And then this one I'm going right 2, up 1. Okay, no big deal. Right 2, up 1, over 1, up 1 over 3. So that still is taking this point right 2, up 1, right 2, up 1. Okay. What do we have now? Oh, my favorite, reflections. I'm sure you guys love these. Reflections in the x-axis, just take all your y coordinates of your points and make them negative. So this one's on the x-axis, so that doesn't do anything, but this one is 1 away in the positive direction, so it's going to be 1 away in the negative. This is 2 away, so it's going to be negative 2 away. And there's our graph. And then finally we have our last one. We're asked to graph, which is this one, and we have a reflection and a horizontal shift and a vertical shift. So there's the 3 parent points. It's always, always, always easiest if you reflect first. So here are my reflected points. And now I'm going to move everything left 4 and down 1. So this point actually stayed the same until now. 1, 2, 3, 4, down 1. And then I'm not moving these. So one trick for you is after you reflected a point, if you want to cross it out. I didn't cross this one out because it's the same point, reflected or not. But you might want to cross those out just so you don't lose them. So I'm going left 4, down 1, left 4, down 1. So now the dolphin, instead of jumping out of the water, once it's reflected, it dives into the water. Alrighty, moving on. Now we're given the graph. We see the dolphin jumping out of the water here, so we need to write the equation. It's not stretched at all, so what happened to the graph is that the graph looks like, instead of starting at 0, 0, now it went up 2. So we can see it goes up 2. How do we write an equation? Well, does that go in with the x or not in with the x? If you go up or down, it doesn't go in with the x. So that's that piece. Alright, let's take a look at the next one. So it started here and now it's gone 4 units. You have to be careful, you have to watch your scales. So it's gone right 4. So right 4, what we've been doing is saying, okay, then x equals 4, right? But we're working backwards now, so this is going to be x minus 4 equals 0. Subtract 4, subtract 4. So that's what's going to go under the square root. Some of you have it memorized as just the opposite. If we ever get into y-axis reflections, that's a little tricky, but we'll see. We'll cross that bridge when we get there. Oh wow, here's where we started, and I've gone right 4, nope, not right 4, right 3. There's my locator point. It's like my starter point. I know this is 3 because it's in the middle, and then that must be -1. So I went right 3, so that's a horizontal distance, and it's right 3, but you can see I just wrote the wrong thing. Should be x minus 3, right? Because I went right 3, and then I went down 1. That right 3 is going to make it be a minus, and no, I just did it again. Just seeing if you're paying attention. -1. Ooh, can you see that the dolphin is diving down? So that means we have a negative, so reflect over x. And then the next thing we can see is we moved left 3. So because we went left 3, that's going to be x plus 3. Sweet. Alright, let's go ahead and flip it over. So now we're going to go over the difference between horizontal and vertical stretches and compressions. So you guys have already learned this, but we're just going to revisit it. First of all, if you're going to do a vertical stretch, the number is going to be in front, and it's going to be a whole number. If it's a vertical compression, it's going to be a fraction, and you're going to multiply the y values either by the fraction if it's a fraction or the whole numbers. Okay? Also, if there's a negative in front, it's not in with the x, it's going to reflect over the x-axis. And this is because that negative is going to take all your y values and change the sign. So if I had a point that was right here at -1, 1, I keep the y value or the x value the same, but this says change the y values. So that would be -1, -1. So that's a reflection in the x-axis. On the other side here, we end up with our horizontal stuff. So first of all, you're going to be multiplying the horizontal stuff by the x values. So again, multiply your x values. The difference with horizontal is that we have to do the opposite of what we're actually seeing. So if we see a fraction, we actually multiply by a whole number. And if we see a whole number, we multiply by a fraction. This all has to do with equations being in the term of like y equals instead of x equals. So even like in this kind of thing, we set it equal to 0 so we can see, and we also know it's the opposite. So it's the same thing here. One other thing we have is a reflection in the y-axis. So reflection in the y-axis means if I have a point here, it reflects over to that side right there. So what you notice is that your y stayed the same, right? This is 1, 1, but your x's changed signs. That should make sense because the negative is in with the x. Okay, so let's take a look at these and see what we can do with them. So this one, I like to read my equations from left to right, even if the questions aren't in that order. So I come up, the 1/3 is not in with the x, so that's going to be a vertical. And it's going to be a compression. And the way I know it's going to be a compression, the way I have it memorized, is if I end up multiplying by a whole number, not what's in with the numbers over here, not this part, but if I end up actually multiplying by a whole number, it's a stretch. And if I multiply by a fraction, it's a compression. Okay? No matter what. So this one, I have 1/3. I multiply all the y values. So it's being by a factor of 1/3. Remember, we love the y one because we don't have to do anything. We don't have to flip it or anything. And then it's going down 7. Okay, let's go ahead and look at this guy over here. All right, so we have, we come up and we see that there is a negative and it's underneath the square root. So technically that is in with the x. So that's going to be a y-axis reflection. So let me show you the difference here. I'm going to put my finger on two problems. So over here, the negative is out in front of the square root, and under here it's underneath it. So that's what the difference is. So this one's definitely y-axis. And it is, the 3 is under the root, it's in by the x, so it's horizontal. But once I circle horizontal, it needs to be the reciprocal. So that one is 1/3 as well. So I would multiply everything by 1/3. So that means that it's a compression. And then I'm going to go the x minus 1. The 1 is in with the x, so I'm going to go right 1. Okay, let's move on to this next one right here. Again, I like to go left to right. So I see a negative first, so it's going to reflect across the x-axis. And then it gets to 8. That's not underneath the radical, so it's vertical. I love vertical because I just do what it says. So it says to multiply by 8, so it's 8. The x minus 5, oh, that's in with the x, so we're probably going to have to do the opposite. Yep, so we're going to go right 5, and then the plus 3 is not in with the x, so we're going to go up 3. Okay, plugging right along here. So we get to this, and I see a 1/4. It's underneath a radical, so it's in with the x, so it's horizontal. And whenever we do something horizontal, we have to do the opposite. So this is actually going to be stretched by a factor of 4. And I know it's a stretch because I would be multiplying all my x values by 4 if I were asked to graph this. Then I have the x plus 5. So that gives me -5. So I am going to be going left 5, and then -9 would be down 9. Okay? And last but not least, we have this guy right here. The 1/5 is out in front, so it's vertical. And I love vertical because I get to do exactly what it says, 1/5. So I am going to be compressing this because compressions are the fractions that you multiply by. Then I have an x plus 7. So I get x equals -7. So I'm going to be going left 7, and then the last part of mine is down 9. Alrighty? Great.